The next equation for chapter 13 is called the ideal gas law. It is PV equals nRT. P is pressure, V is volume. Now N is something new as in what you're seeing, but you already know how to solve for it, and it is the number of moles. R is the ideal gas constant. These are numbers that you just get to plug in, but it's based off of your pressure label on which number you're going to use, and they are also found on your cheat sheet. Backside, right underneath the solutions. Backside, right over there.
Right here. Our values.
So that number you will always know. You're going to plug that right into the equation. It's based off of which ATM or kilopascal or even millimeters of mercury if you're using your textbook. We don't have that one on the cheat sheet, but
no.
Maybe next year. And then your temperature is your letter T, and it again must be in Kelvin for you to solve for the equation.
Yes.
So let's jump into it.
Okay.
What pressure in atmospheres, so we got PV equals nRT is the equation we're going to be using. What pressure in atmospheres will 18.6 mole of methane exert when it's compressed in a 12.0 liter tank at a temperature of 45 degrees Celsius? So we know the number of moles. We've got 12 liters is your volume. We've got our temperature is 45, which is going to be plus the 273, which gives you 318. And we need
we're looking for
pressure, and our R value. Now the R value, because the pressure is in ATM, because it says what pressure in ATM, we are going to use on our cheat sheet, we're going to look directly there, find the R values, and we're going to use the first one because it says 0.0821 ATM, and it has a lot of labels. It's got dot liter divided by mole times Kelvin. So that is where we get to cancel out all the labels
yes.
within the problem. So there's a whole bunch of them. So what we got to do now? Plug the numbers in. So we want to find P.
So we're going to take nRT divided by V.
Yep. So you've got your 18.6.
We'll do parentheses.
All right. And then your 0.0824.
Yes.
Nope, 21. Times your temperature, 318. Divided by 12, because we moved the volume, it was being multiplied. To get rid of it, we're going to divide. And we find our pressure to be 40.47 ATM once we plug it all in. ATM. There you go. These these aren't too difficult of problems. You just have to be able to pull the information out of the story problem. Go ahead, underline, label wherever you need to do, make a giant chart, see what you have and what you don't. If you see the number of moles, probably going to be using the ideal gas law.
Yes, and you'll see this throughout college. It's like the only law that I remembered. Because I don't know why. I used it so frequently.
Yeah, and it's pretty easy. Just plug and chug. Are you ready?
Ready.
13.3 has one topic and one topic only. Here we go. Gas stoichiometry.
Yay!
I know you're so excited here, people.
You thought we were done.
We thought about renaming this gas switcheroo so that you don't get frightened by the stoichiometry, because this is actually pretty easy. We think you can really do this by now.
Switcheroo.
So it's not gas stoich, it's gas switcheroo. All right? So positive attitudes is what we're going to do. You will need to use the mole ratio from a balanced chemical equation to convert mole to mole, and then plug that mole value into the ideal gas law. So you got 3 steps. Step 1, convert gram to mole using your triangle. Here it is again. Convert mole to mole using the mole ratio. And then use that mole value to plug in for N on the PV equals nRT. Ready for the problem?
Yep.
All right, here's our example. A piece of aluminum with a mass of 4.25 grams. Here's our gram, and it tells us with aluminum. So Mrs. Kelly is going to be working on changing that gram into moles.
How do you do that?
Triangle.
You know this.
Divide by the molar mass, 27. It is used to generate hydrogen gas by the following method. Now here we were really nice. We gave you a made and balanced equation already. And it says the hydrogen is collected at a temperature of. So what they really want, they started you off with aluminum, they want their answer in hydrogen.
Mm-hmm.
So we have to take the moles of aluminum, there we go, and convert that into moles of hydrogen so we can plug it into PV-nRT.
And what we're really looking for is the volume of hydrogen.
Two different problems to get to the PV-nRT.
Mm-hmm.
So let's multiply that by our mole ratio. We're going to take aluminum is on the bottom. We got 2 moles of aluminum and 3 moles of hydrogen gas. Then we're going to end up with 0.236 moles of H2. So now that's our N value. We've got our moles. So if we're going to plug that into PV-nRT, so let's go through the rest of the problem here.
Okay.
We've got a temperature of 15 degrees Celsius.
Okay. Sorry, I was already writing the pressure.
Oh, fine. Well, then let's just fill it into the equation as we go along.
Let's do that, yeah.
All right, so we got 94.4 kPa.
Mm-hmm.
We want to find volume. What volume of hydrogen is produced? So we've got our V as our unknown is equal to our N, which we just solved for, 0.236 moles. kPa is our pressure volume. So we have to go to our cheat sheet, look up the R value. You're going to use for kPa 8.31 because that's the one that's got labeled kPa.
Mm-hmm.
And then your temperature, you got to take your 15 degrees, add your 273, and you get 288.
Oops.
Did I
Yep,
not?
that's what you get.
All right, we got to get V alone. So we're going to multiply the 3 and then divide by our P so that we can get that alone. Plug it all in. Boop, boop, boop. Look at you crossing stuff out.
Oh, yeah.
All right, once we get that all plugged in, we get a volume of 5.98 liters of H2 gas. So we started off with a piece of aluminum. We changed it in to see how much hydrogen gas are we actually going to be making in volume into our tank. Done.
Okay, and why can't we just go moles of hydrogen gas and use this little triangle in front? Because I know I'm going to have some students try to do that.
Gram to mole of hydrogen gas.
Because you've got liters of gas. Can you find the volume using that?
You don't have the liters yet. You're solving the liters.
Yes.
So you can't use that one yet. It's not
So
there.
Well, you can't take the moles and multiply by 22.4 because you have specific pressure,
Yeah.
R values, and temperatures.
It doesn't say STP.
Mm-mm.
Not at all.
Okay, so make sure that you're going through the whole ideal gas law when you do gas stoichiometry or gas switcheroo.
Gas switcheroo. Not
Right.
stoichiometry anymore. Get that mean word out of your head. Go
Well,
gram to mole,
Mhm.
mole to mole,
Mhm.
put it into PV-nRT.
Yes.
3 steps. Very easy.
Mm-hmm.
You can do this.
We'll practice in class.
Yay!